Hi guys, for this video I will talk about chapter 3. It's about probability. Recall that in statistics we use sample data to infer the nature of population, but in probability we use the population information to infer the probable nature of the sample. So probability, we use population information to infer the probable nature of the sample. In probability, we have three elements. First, experiment. Experiment is process of observation that leads to the single outcome. It is act or process of observation that leads to a single outcome. And in probability, we cannot predict it with certainty. For example, flip the coin or tossing a dice. Next one is sample. The sample is the single possible outcome of the experiment. Is the most basic outcome. For example, flipping the coin, the most basic outcome would be head or toe. For a sample space, is a collection of sample point of an experiment. For example, flipping two coins in one time. The sample space would be head and head, or head and toe, or toe and toe. We flip two coins in one time. The outcome would be these three. And the rule of the probability, we have two rules. The first one is the probability will be between 0 and 1. It cannot be less than 0 and cannot be more than 1. The second one is the probability of all sample points within one sample space, when we sum it together, is will equal to 1. So sigma p equal to 1. For example, flipping one coin, the possible outcome can be head or toe. So the probability of getting head is 0.5, or toe, which is also 0.5. So head equals 0.5, toe equals 0.5. It will be equal to 1. In an easier way, you can think that 1 is 100% and here is a 50%. 50%. Okay, so we move on to the next part, is events. The event is the specific sample space. The specific sample space For example, these three, if I want the outcome that have at least one head, so we're gonna count only these two, but we're gonna exclude this one. The simple event is the event that contains only one sample point. Contain one sample point. But a compound event we contains two or more sample points. The next one is the steps to calculating probability of events. First, we're going to define the experiment, which is describe the process used to make an observation. Describe the process. Okay, next one is list the sample point. To list it, we have two ways to visualize the sample space. First, tree diagram. So for example, we're gonna flip one coin 2 times. The first time can be either head or toe, and the second time can be either head or toe and head or toe either. And the next one is Venn diagram. The Venn diagram is to write down all the possible outcome of the events. We're going to use the same example with flip one coin but 2 times. So the outcome should be head and head, head and toe, toe and head and toe and toe. The third is assign the probabilities. So for example, head and head, head and toe, toe and head, toe and toe. We have 4 possible outcomes. And here is the probability will be 1 over 4, 1 over 4, 1 over 4, 1 over 4. Next step is determine the collection of sample points contained in the events of interest. If in this example I want the outcome that have at least one head, the correct event that happened will be head, head, will be here, here, and here. So, and then we move to the last step, which is sum the sample points probability. So we will sum here, here, and here, which is equal to 3 over 4 or 75%. So we can say that the probability of get at least one head from flipping coins, one coin twice is 3 over 4. The next part is combination rule. Is the number of different samples when we draw the elements from the bigger population. For example, here we have For example, we have 15 balls in the bowl. If I want to draw 2 balls out of the bowl, what are the possible samples will be drawn from the bowl? So we can denote it like this. First, we have 15 balls in a bowl, but we want to draw only 2. So how many outcomes it would be to calculate it is to use this formula. First, the big N factorial divided by the small n factorial multiplied by big N minus n factorial. For example, 15 is a big N because it's a population and we're gonna pick only 2. So 15 facts divided by 2 facts with small n multiplied by 15 minus 2 factorial. The factorial is we're gonna multiply from that number until 1. For example, 15 factorial is 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6, 5, 4, 3, 2, 1 divided by 2 factorial is 2 times 1 multiplied by 13 factorial. This one is 13. So it's gonna be multiplied by 13 times 12 times 11 times 10 times 9 times 8 to 1. We're gonna use a basic mathematics, which is we can eliminate here and here, because 13, 13, 12, 12, 11, 11, 10, 10, 9, 9, 8, 8 until 1. So we're gonna have only here, so we will have 15 times 7 equal to 105. So it means that we will have 105 possible outcomes from draw 2 balls from the 15 balls in the bowl. And the last part for today is union and intersection. So first, union. Union is when A or B or both occur on a single performance. Union is when A or B or both occur on a single performance. So here, so you're gonna count at this part of the circle. Why we don't count over here? Because here we called it intersection. Intersection is when A and B are occur on a single performance. You can see we have the statement or and. Or is mean it can both occur or A occur or B occur, but and is mean both have to occur on a single performance. We're gonna do a die toss experiment. For example, A is even number and B is toss number less or equal to 3. Number less or equal to 3. On the diagram, we can write event A like this. Even number on the dice we have 4, 6, and 2. The reason we write 2 at the middle because it's also the number less or equal to 3. So it's also event B. So 2 we call it intersection. And union we have 1, 2, 3, 4, 6. Because 5 is not an even number and is not less than or equal to 3. So to calculate the probability of A union B is assign the probability here first is 1 over 6, 1 over 6, 1 over 6, 1 over 6, and here also 1 over 6. The reason that is 1 over 6 not 1 over 5 because on the dice we have 6 face of the dice. 1, 2, 3, 4, 5, and 6. So the probability of single face is 1 over 6. So after we assign the probability, we have to sum it. So it's equal to 5 over 6. And the probability of A and B or intersection is 1 over 6. Okay, that is for today. The next part will be the second part of chapter 3.